In this video, I'm going to prove an important theorem. The square root of p is irrational for any prime p. Proof. If you like seeing mathematical proofs, subscribe to my channel, as that's all we ever do here. Theorem proofs. Facts proof. Conjecture, well, maybe not conjectures, lemmas proof. Okay, well, we want to show that the square root of p is irrational if p is prime. Okay, so suppose otherwise. Suppose the square root of p is equal to a over b, where the GCD of a and b is 1. That means a over b is in reduced form. Okay, well, this statement tells us when we square it that pb squared is equal to a squared. Well, that implies that pb times b is a squared. Oh, you mean that b divides a squared. A squared, there it is a multiple of b. It's a multiple of b. So b divides a squared. Okay, now suppose that b is greater than 1. That implies there exists a prime p such that p divides b. Okay, now if p divides b and b divides a squared, then p divides a squared. Not if. Since p divides b, and in turn b divides a squared, that implies that p divides a squared. That is, p divides a times a. Now, since p is prime, it has to divide one of these. Well, pick whichever one you want. P divides a. Wait a minute. P divides b and p divides a. That implies that a common divisor of a and b is equal to p. Okay, that's a common divisor. The greatest common divisor will be greater than or possibly equal to p. Well, that's a problem because the GCD of a and b is 1. Oh, and p being a prime is bigger than 1. So that's a contradiction. The GCD of a and b is not bigger than 1. The GCD of a and b is 1. But that came from b being bigger than 1. Now, maybe I didn't say it anywhere, but a and b are positive. P is positive. P is bigger than 1. Okay, so now suppose b is 1. So let's go So this here would imply that p is equal to a squared. I get that right here. but that would imply P is not prime. Okay, so what happened is we can have the square root of P equaling A over B. Okay, the square root of P can equal A, because that would mean if the square root of P is equal to A, that would mean that P is A squared. But A squared has factors other than 1 and A squared. One of its factors is A, which means P is not prime. P is not prime. That finishes this proof. You just love proofs like this, subscribe to my channel. See you guys in the next video. Watch and learn.